Hello and welcome to Naming Molecules with Neil Sillins. Today we'll be naming a brute of a molecule, but before we get going, let's have a recap of IUPAC and what their naming rules are. So the IUPAC is an international body with the responsibility of standardizing rules on naming molecules. So we all know what types of molecules is. The name's consistent and there can be no confusion between different molecules and isomers that can form from having the same amount of each element but arranged in a different way. So every chemical molecule arranged in any shape or fashion has its own unique name, therefore there is no confusion whatsoever. However, it can be a little bit complicated naming them, so we're going to be covering some of the rules that they set out today, and we're going to be naming a bit of a challenging molecule today though. Here is today's molecule. It's a very complicated molecule that might never have actually been created by chemists so far. We can name it by following the rules set out by the IUPAC. We're going to be set out to do this today. So you might be saying, why don't we just use a molecular formula? Keeps things nice and simple. So we could give this a molecular formula like this, but it doesn't show where everything's connected. These things could all be connected in different orders. We can create many different isomers from this. So we need a name to make sure we know exactly what we're talking about when we talk about the molecule. So if we return to the molecule, we can start it by identifying the functional groups present. So there are 4 functional groups present in this molecule. The first of which is a ketone. Ketone is a carbon double bonded to an oxygen atom. And it has to be a carbon that's not at the end of a chain, because then if it was at the end of the chain, it would be an aldehyde. So they're different functional groups. So we've got a ketone. We've got a bromine bonded to a carbon, so a bit of a haloalkane going on here. We've got a nitrile group, so that's a carbon triple bonded to a nitrogen atom. And we've got an amine, so a carbon bonded to a nitrogen and then to 2 hydrogens. So we've got 4 functional groups present. So there's some beginning things about thinking about naming this molecule. We also need to consider the carbon chain and how the carbon chain is structured. So we need to first of all find the longest carbon chain, and that can be in any way or form. It can go around corners, it can be different, it can in some molecules, and it might not look this. You might not find the longest one the way you're expecting to find it. But in this one, it is the longest carbon chain is 9 carbons long and it goes across the way. So I'll bring some numbers up on the carbons. You can see that this carbon chain is 9 carbons long. So there, and the longest carbon chain serves as the base of the name of the molecule. So the base of this molecule is going to be called nonane, so it's got 9 carbons. But we've also got a couple of other carbons bonded onto carbon 4, so we could call that ethyl side group, and that's caused by having 2 carbons bonded, two fully saturated carbons bonded onto the 4th carbon. So now if we want to have a quick summarize of what we know, so we know there are 4 functional groups present, and we know we've got a main chain of 9 carbons with a side chain of 2 carbons. So just thinking about actually how we're going to name this thing, we need to first of all consider the priority of the different functional groups we've got. So these are a summary of some major functional groups that do exist in chemistry, with the most highest priority ones at the top and the lowest priority at the bottom. So alkenes are much more higher priority than arenes. So if we highlight the ones we've actually in this molecule, we know we've got haloalkane, we've got a nitrile, ketone, and amine. So the haloalkane is going to take a much higher priority in naming than the nitrile, then the ketone, then the amine. So if we return back to having a think about what we have, we can begin to actually name our molecule. So I've put a bit of a summary of the things we've got attached. So we're going to start by looking at the base. So we're going to look at how long the main carbon chain. As I said earlier, since we've got 9 carbons, and we're going to number it in this order because this creates the lowest numbers when we have to start specifying where things are attached. So you always want to use the lowest numbers possible. We're going to begin here. So the haloalkane is the most highest priority. So we're going to, after we've discussed how long the main carbon chain is, nonane, the haloalkane is the next we're going to add to the chain. So that's 5-bromo-nonane. But we've still got more things we need to add to the chain, so we'll keep on going. So we've got a nitrile bonded to there, 5-bromine nitrile. I should actually have 9 nitrile in it so you can tell which end it is, but I will try and add that in as we go. Then we've got the next thing, because that's nitrile's the next highest priority. So we now could try and put the ketone in. So 5-bromonon 3-anone nitrile, because the ketone's bonded to the 3rd carbon. We're next going to have a look at the ethyl group, 5-bromo-4-ethyl non-3-anone nitrile. Then we're going to put the final functional group that we've got in today. We've got our amine group. So we can have 5-bromo-4-ethyl 7-amino non-3-anone 9-nitrile. Whilst I have missed that 9 out, we do need to put it in, as we need to specify which end the nitrile is located in the chain. So today's molecule is 5-bromo-4-ethyl 7-amino non-3-anone 9-nitrile. And let's just draw that 9 in there. So we know that that should have a 9 in. It should be like that. Like that. So we know where everything is bonded in the chain. So, phew, that was indeed a difficult molecule.